All righty. Well, everybody, welcome. I'm Steve Lander, Director of Pavement Management at WithersRavenel, and today's Lunch and Learn is about PressurePave. And this happens to be our 44th episode since January of 2021. So I'm glad everybody could make it. So this is a versatile hybrid preservation treatment. It uses a pressure injection, which pushes material into the cracks. And it simultaneously puts down a durable, thin asphalt overlay. So looking forward to our presentation today. I hope everybody's staying well in this time where people are still getting COVID. I thought that was over, but people are still getting it. So I hope everybody's safe. So the intent of these lunch and learns is to introduce you to new products and practices, broadening the maintenance toolbox, and just trying some new types of treatments. And a lot of times that comes in the form of a pilot. And I think Mike Horney from Lexington, he'll be on here today, and they're actually going to be trying this out sometime in the spring, so we can talk about that a little bit. In general, anybody who needs PDHs for keeping their peas, we're going to be putting a link in the chat, so you click on that, and you'll get a certificate for one PDH. The WithersRavenel website link is there, as is the PressurePave link, and then our email addresses will be posted. So these things are going to be posted throughout the Lunch and Learn. So these Lunch and Learns are all recorded. So if you want to go back and watch one, just let us know. And also too is that we can provide you with a copy of the presentation after. And we also ask that maybe providing us some feedback of how well we're doing. Are there topics that you want to cover? I know we struggled with traffic control because the folks with traffic control are usually so busy, and then we finally got one and knocked it out of the park. So the format is that Mark and Brian Donaldson are going to be presenting for roughly 45 to 50 minutes. We have a lot of information to cover, so typically we would answer questions during the presentation, but we want to make sure we get through all the materials. So save up your questions or just type them in the chat, and we're going to cover them at the end. And if we don't get to your question, we'll answer it after the Lunch and Learn. So with no further ado, I'm going to turn it over to Mark and Bryant for introductions.
Sure thing. My name is Brian Donaldson. Over here is my dad, Mike, and he and I have been in this for a long time. Him way longer than me, if you can't tell. And he is my dad, so I can make jokes like that. But yeah, I've been doing this for a little while now. I grew up with it. My grandfather started a quarry. My dad and his brothers took it from there and developed a construction company where they invented multiple patents around the preservation industry. And we'll talk a little bit about those. But what my job is in this company is to go around the country and help start PressurePave programs, select good candidates, provide estimates, evaluations, things like that. And what my dad does is he's the inventor of this whole system that we're going to be talking about. So he started in the aerospace industry a number of years ago, brought that knowledge from developing fuel systems for fighter aircraft, brought that over to this industry, and we have PressurePave. So anyway, we're going to go in depth on that. I'm going to give a brief summary of what this system can do just real quick, because I did see a question in the chat already. This system is very unique in this whole industry, not only because of its unique method of application, but its results, its longevity. So one of the questions I already saw was, how often do you reapply this? Well, this system is going to last on the road 12 to 15 years. And we'll get into what makes it special beyond that, but we designed this system to pressure inject cracks with a mastic that is going to help treat alligator cracked streets. So PCI is typically 40 and above. and it's drivable in less than 30 minutes. So anyway, I just breezed over the highlights. My dad's going to get into the weeds, and I'll let him take it from here.
Yes, good afternoon. I appreciate everyone's time today. I know it's valuable, and hopefully we can provide some good information to you. I've been in the pavement preservation business for well over 30 years. So if you have any questions now during this or after about any techniques out there, I have been involved virtually anything that's out there in the preservation industry, and I've worked with folks over the years, literally from coast to coast. I've been involved with chip seals, hot rubber crack seals, cold mix paving, hot in place recycle, cold in place, spray applied oils and things of all nature, aggregate filled or not aggregate filled. So a lot of things I've done, a lot of things I've tried to do and failed at, honestly, learned from a lot of mistakes. And but as you kind of find from today's presentation, all that experience has really kind of led me into the PressurePave system, and a little bit biased with it, but we really think pretty highly of it, and hopefully we can pass some of that information on to you today. So I'm going to go ahead and jump in with and share this presentation. Things a little organized here. All right. Hopefully everyone can see that. Steve, I'll go ahead and turn it back over to you for a minute.
Yep. So just an overview of best management practices for pavement management. This also could be asset management. At the very top, it starts with a plan, right? So, we ask our municipal clients like, hey, what kind of level of service are you looking to achieve? And sometimes nobody knows. And, we're just fighting these little fires here, but you got to know, what type of treatments we're going to use. How much money we need to spend to get to some desired level of service. And it's from this plan that determines the type of pavement condition survey we're going to get. Do we need life cycle modeling? A lot of times, for larger municipalities over 50 miles, you're typically going to use life cycle modeling. Then like what we're talking about today, what kind of maintenance are we going to be applying to these roads? And there's something that we can use at all levels of the deterioration curve. And then taking that information from our plan through the survey to selecting the treatments and putting together concise contract documents, providing full-time construction inspection to make sure it gets done right, and then tracking how well our treatments are performing over time, because it comes down to dollars per square yard year. And something that got my attention early on was those other assets. A lot of times we just think of pavement, but there's water, sewer, and stormwater that also affect the pavement, and we want to make sure that we're handling those fixes before we do the pavement, so we can also model those. And then the funding, which is not so readily available for pavement, but we can locate funding for other projects like your water, sewer, and stormwater. So this is a program that should be looked at every year and addressed. And when you use these components, you will have a successful pavement management or asset management program. Turn it back over to you, Mike.
All right, fantastic. Thank you. Who we are. As Donaldson Construction, I'm involved with 3 different companies that we manage, take care of. We have a rock quarry, so we are an aggregate producer in southern Missouri is where we're located. Had this quarry for over 50 years. So we've been in business a very, very long time. And as Brian indicated, my family goes back a long, long way in the construction industry. But we also produce our own emulsion. We develop our own technology, our own equipment, and we are a contractor. So we're honestly very unique in who we are and what we do. And we do this by choice and almost forced into it over time, because I'm an engineer first. I'm not a sales guy. And so quality control, all those things that I learned in an early age in a different career, I knew I had to bring to this industry, which was and still is. Well, you pick a local aggregate, you find somebody to make some oil, you go out and you do a surface treatment, and and really it's a flawed method. It's a flawed way of doing things. And we found long time ago, the best way to produce the best results is going to be hand pick an aggregate, hand pick the emulsion oils, the oils that go into producing this asphalt, and then all the other things along with it, and finally the guy that installs it. So with us, you're pointing the finger at one person, one individual at the top as far as quality control, and so that's really why we do what we do. Everything that we produce does, like I say, come out of this quarry that's 800-acre quarry in southern Missouri. And in the genre of products that I'm talking about, which is utilizing aggregates and emulsified oils, which is the industry standard for surface treatments, generally speaking, they're all made in that same genre of rock and oil. We have just God blessed, have some fantastic aggregate at this quarry, and then our own emulsion that we specifically design for that aggregate that gives us the best results. And I will dive into that in just a second. As a result of our specific methods and everything, we have several United States patents, and I actually just got another one approved a week or two ago, and I've got others that are in the process of being approved. So and you get these, they don't just hand these out. You get these because they're innovative. They provide a great benefit to the industry. And again, you're going to see some of the results of what we do and why we're able to achieve those patents. If you're not familiar, if you haven't seen what the PressurePave system yet through the videos, I would highly encourage you to visit our website and seek that out and watch some of these videos. But what the PressurePave system is actually putting down two different products at the same time. And I'm going to get to show that in just a second here. But the driving surface is the MAQS, Modified Aggregate Quickset. And we actually have a patent on the driving surface alone. And I've been doing this driving surface for about 20 years now. So a lot of longevity with it, a lot of great results over the years. And then we incorporated at a later date, much later date, probably about 5-6 years ago now, the pressure injection crack system and stress absorbing mastic that goes underneath this driving surface. So if you look at the three options that we currently have, and we currently do, the 1/8 of an inch, the 1/4 of an inch, and then the 3/8 of an inch. The 1/4 of an inch is kind of our bread and butter. That is the type 2. That is the one that we utilize most in residential areas, in light collectors, some heavy collectors. And I'll show you some longevity pictures of that in just a second. So that one's really been our bread and butter. We've done the longest. 3/8 of an inch is something that we developed later to get that same longevity out of some heavy arterials. So I've got that product currently on an arterial in our area that's seeing 35 to 40,000 cars a day. That's a lot of traffic. And so in the city application, that's a lot of traffic. And so we have gone to the 3/8 of an inch version in those applications, but the 1/4 of an inch is the one that, as Bryant indicated, you put that on a light collector residential street. We've got a long history of 12 to 15 years of life out of that, and actually still looking really good. And I'll dive into that in just a second. If you're not familiar with this, we'll kind of describe this a little bit in specifics here, but this is a train that this machine right here is being fed all the raw materials off a nurse truck out ahead of it. In fact, you can actually see the aggregate that is being fired into this unit. So from the nurse truck into this machine, we're getting fed raw materials, the aggregate, the polymer modified emulsion, water, and Portland cement. And all those components are mixed on board into an onboard pug mill located right about in here. And that's what this gentleman right here is doing. He is overseeing the operation of the manufacture and the installation of the driving surface. And that's what these guys back here are doing. This is a variable width, equivalent to an old style drag box if you've been in the paving business a long time. But this is a series of blades, rubber blades on the back that actually sets the depth and the texture of the driving surface. And so this, some things in here that are unique to us, and some are common to the industry. But that is the production and manufacture of the driving surface. But also what is being pumped on board to this unit is the PressurePave sealant. And that is what we're doing in this area right here. So we are injecting, pressure injecting a material onto the pavement ahead of that driving surface. This is our PressurePave sealant. And what it's, this device that we have a patent on is a scissor-like mechanism. And in each one of these, this mechanism actually has about a 1 foot box or chamber located across that driving surface. Now, why did we go with a 1 foot box? Well, if you think about, most roads are not flat. They have a contour to them, either by design or through age or whatnot. And so in order to get these bottom of these boxes flush with the pavement, you can't do it with one long line segment. You do it in individual line segments to be able to contour to the surface. So we are pressurizing and pressing down to the pavement each one of these individual boxes or chambers. And these boxes are open at the bottom. And I'm actually firing material into these chambers. And so we're creating a positive pressure gradient in these chambers, so that as this whole unit goes down the road at about anywhere from 200 to 300 feet a minute, we have ample material and we have ample pressure developed on the underside of these chambers, so that as that open chamber sees a crack in the road, we actually can have ample material and pressure to fill it. So all the cracks, large and small, are going to get filled with this PressurePave sealant. It's very, very important. The other thing is, I have some people say, well, are you just spraying something ahead of your paving operation? No, absolutely not. It's one of the lessons that we learned a long time ago, is two things. One, a spray application makes a lousy crack filling operation. And two, if you go into a neighborhood or any residential area, anywhere, you know, in a city application, and you try to spray something, you are opening yourself up for problems with any kind of gust of wind or malfunction at all. Been there, done that in many, many years of experience in chip seal and fog seals and everything. And so the pressure injection is the way to go. And I'd illustrate that here. If you go in and chip seal a road, or you do some sort of fog seal, whether it be aggregate filled or oil by itself, you're relying on gravity to fill the cracks. The pressure injection system, this is a photo that was taken right after the machine passed. So you can see the color of the brown color is the emulsified asphalt. It's fresh. That literally will turn black in a matter of minutes and be drivable, as Bryant indicated, usually sometimes as little as 20 minutes, but usually on average, or little as 10 minutes actually, but usually 20 to 40 minutes is an average crossing traffic. But we really like showing this photo because you can see all the additional liquids that are down into these cracks as they're highlighted with darker lines. And so you can see all these cracks that were deep, wide, etc., and they're all full of PressurePave sealant, as well as the fresh driving surface right over the top. Again, think of what I'm describing here in this system as accomplishing three things. Yes, we're putting down two different types of material, designed completely different, but I'm actually accomplishing three different things. The first thing is the crack injection. The second thing is I'm taking and I'm using a series of rubber blades and I'm striking off that excess material. I'm creating a windrow ahead to force more of that material into those cracks as much as we possibly can squeeze in there. But we're leaving behind a thin membrane, if you will, which it's the same material that's in the crack, but it is a stress absorbing mastic. Now, what's in there is proprietary, but I will tell you that it is a polymer modified emulsion and it is an aggregate. You cannot just use a simple oil, because if I do, I'm going to create a slip joint. It's very important that that is an aggregate filled material that leaves me a rough texture to where I can, my thin treatment, my thin driving surface over the top is going to be able to have something to grip to and bond to without creating a slip joint. And we test for that in our facility to make sure that we're not creating a slip joint. In fact, I've seen failures where people try to do this and do create slip joints. So Again, I've got some other goodies built into this that makes it a stress absorbing mastic that is highly crack resistant. And then the third thing is the driving surface, and that is our wearing surface, whether it be the 1/8 of an inch, 1/4 of an inch, 3/8 of an inch. We designed that to seal the pavement. And as you can see from this test, it takes water, constant saturation of 6 days before water would eventually penetrate our 1/4 of an inch surface. Now, I'm going to show you here in a little bit about some other genre of products that allow water to go right through it. But if you have ever heard, I know people know about chip seals and things, with slurry seals, micro surfacing in particular, those are wearing surfaces. And I don't want to get lost in the weeds on where that all originated from. It actually came from Europe and the Autobahns, but it was actually, a lot of that is designed to be a wearing surface. If you talk to anybody in our industry, it's common knowledge that those are wearing surfaces and not sealing surfaces. So it really took us to rewrite a spec outside the box to be able to and actually have the right aggregate to be able to have something that is actually sealing the pavement, which is what we're after. So what we're after is this, is we've done our cutaway here, and you can see the PressurePave sealant, and you can see the wearing surface, the 1/4 of an inch wearing surface over the top of that. Now we're virtually water impermeable. I mean, and not only water impermeable, but the other thing that we're really trying to shoot for is to keep the oxygen out of the pavement and keep the volatiles, those lighter oils, those distillates that originally was in that hot mix paving originally, we want to keep those trapped in there. To be honest, the refineries and the byproduct, the waste product that is the say the 64-22 bitumen, those are waste products to a refinery, and they have gotten really good over the years. If you're as old as I am, you've been doing this a while. The asphalt is not what it used to be. The asphalt we get from refineries is not what it used to be. Back in the 70s and 80s, it was much better product. It is slowly, the refineries are squeezing more and more of the goodies out of it, the diesel fuels and the home heating oils and all those things that they're able to get out of there leaves a more brittle product behind, because they are shy on some of those good distillates that were in there in some of our old specifications and the old products. So we want to keep those trapped in there. We want to keep the water out of it. We want to keep oxygen away from your pavement. It's very important. If you look at some studies, you will find that just like rust on a car, just like when you slice and open an apple and you watch it turn brown before your eyes, that is oxidation. That is a simple exposure to oxygen. And that bitumen that comes from the crude oil, those dead plants and organics that have been buried in the earth for millions and millions of years, as you bring those to the surface, you expose it to the surface, oxidation takes place. So as soon as you first lay that brand new hot mix overlay, it is going to start deteriorating from day one. And so we want to keep oxygen away from that as well. What's a good candidate for?
Real quick, sorry to interrupt. I don't mean to interrupt, but if you could go back to the picture of the truck real quick, I just wanted to make one thing real clear. That whole train is not the process. If you could wave your mouse where the front of the truck is. 90% of our work is residential. The other 10% is collectors and arterials and things like that. So this machine is designed to make tight turns, be in residential tight spots, cul-de-sacs, things like that. So just wanted to make that clear. It's different than, say, a hot in place recycle where you need that long train to get into places. This is a mobile operation that can break off into segments, and we can get into residential areas.
Right, exactly. A good point, and I'll dive more into that with the cul-de-sacs and that here in just a second. What is a good candidate for surface treatment? Now, I'm sure everyone here is aware of PCIs. Let's say your scale is 0 to 100. There are all kinds of options out there, many inexpensive, quite honestly. for those that are in the 80 to above, but they're all really, for the most part, designed for keeping your really good roads really good. And can't fault some of those systems. Some are better, products than others, but those are all options available to any agency out there. But what do you do with, if you look at a bell curve, most agencies that we deal with, they're doing well to have their average PCI of 70 or above. Most of the volume of their streets are in this range right in here, in this 50, 60, 70, maybe 80 range. You've got your really good roads, you've got some of your really bad ones, but the bulk volume is right in that middle range. And many times the easy button of mill and overlay is what is designed or thought of first in that type of situation. So if you look at even the photo as the background here, cracking is one of the big reasons why that PCI score gets driven down. I've seen it time and time again. Depends on what program, who's doing it. It's kind of a subjective situation, but cracking is something that will really drive down a PCI score. But yet a road is good, it's solid. Maybe it's top-down cracking. Maybe the subgrade, the sub pavement is solid, but it still gets a lousy score because of the amount of cracking in it. So some people look at that, well, gosh, I've got a lot of cracking in my road. Maybe I need to go ahead and do a mill and overlay. And we have found, and I'm going to show you photos of how we are able to, obviously we can handle 80 and above PCIs quite well. But when you combine our wearing surface with this pressure injection, PressurePave system, we can really reach down into the mid-range PCIs and perform quite well. And I will show you some photos of that in just a second. To kind of illustrate what I'm talking about with the cracking, if you look at this photo, this is one that's probably got a score, I'm going to guess, in the 60s, 70s, somewhere in there, depending on who's evaluating it, what program they're using. And again, a lot of it is going to be based on the amount of cracking. Typically for me, with a chip seal, done it for a long time, a slurry or a micro or anything, fog seals or anything like that, I would not recommend to an agency to do that type of treatment on this type of road. The damage has been done, the cracks have happened, and you can see even from someone going in and going, well, we do a hot rubber crack seal. We've done that. That's a good way to fix or help band-aid the damage of the cracks are there. And that was the tool that we had at our disposal as well prior to the PressurePave system. But crack sealing has its limitations. And some of that is shown right here. It'd be a matter of you went in crack sealed, where would you ever quit? And you kind of see that in this photo here. You look at somebody went in, this wasn't us, and said, well, let me go in and practically patch with it. I go in and, our crew used to be faced with the same thing. It's like, hey, Mike, where do you want us to stop? This road has cracks all over the place. Where do we quit? And I could spend a lot of time talking to you about this, but there are some real compatibility issues with hot rubber crack seal. It's a great product. It's a standalone product. Typically, when you go in and try to do a surface treatment over the top of it, you can really have some problems with your surface treatment over the top of a hot rubber crack seal, whether that be a bonding issue or different expansion and contraction coefficients. It's a great product when it's used in the right way, but the things that make it a fantastic standalone product also can give us in the industry a compatibility issue with trying to go over the top of it with a surface treatment. If you try to go over the top of a hot rubber crack seal with a thin overlay, a thin hot mix overlay, you can run into problems as you go in there, and that hot mix will swell this material to the point where you can your compaction on your hot mix overlay can suffer as a result. And I've seen agencies actually ruin roads with over application of hot rubber crack seal. The PressurePave system, again, as I've said, will fill all cracks, large and small, and that includes the thin ones. Hot rubber crack seal is not made to go into thin cracks. It's cracks that are thin like this, they all have to be routed out. And the reason is hot rubber crack seal is designed to attach to the sidewall of the crack. It's not pressure injected like our system. It's relying on gravity, and it has to get down there and attach to the sidewall of crack to adhere. If you go in there and smear some over the top and then try to do a Band-Aid approach over the top, what happens is you don't get the penetration. And this photo was taken 6 months after application, where it just simply re-cracked. Well, again, these are the issues that I saw in the industry. Again, we were doing this too, but I saw the flaws in it and said, no, we're for two reasons. One, we're going to get all the cracks, and our penetration is going to be through pressure injection to make sure that we are filling the cracks. Just to kind of give you an idea of some of the evaluations and honestly in-field testing that was done actually quite recently. This is a case study of PressurePave versus a double microsurfacing in Rockford, Illinois. And Rockford in the state of Illinois actually kind of got into a conjunction with this and evaluation with this, and really wanting to see, because double microsurfacing is something that the state will has funded typically through their fuel tax credit in the state of Illinois. But PressurePave being what it is, highly unique, et cetera, and they were trying to get the same approval from the state so they can receive that funding as well. So they really wanted to do a side-by-side comparison. And I bring this out and I show you this simply because we are very proud of the results, and it is quite impressive what we were able to see in just 1 year. With any thin surface treatment, and I'm going to tangent here for just a second. I tell people all the time, if I could ever come up with a surface, a new wearing surface that I can put over an existing crack and not have it re-crack, I'm going to retire. That's the holy grail. That's what all of us in the industry would love to be able to do. But the industry standard is 1 inch per year. In other words, if you go in and do a 1 inch overlay, typically within 1 year, you're going to see a crack come back through where there is a crack underneath, a reflective crack, usually 1 inch in 1 year. 2 inches of asphalt, 2 years. Well, any thin surface treatment, whether it be chip seals or micros or slurries or anything, has that same issue. And we were falling into the same boat, being a thin surface treatment so that there's no milling required and all that. We really suffered from the same thing, which is susceptibility to reflective cracking. But the PressurePave system, what we have found is, and is still ongoing and still evaluating it, what we are finding that ductile membrane that I'm putting underneath there, which makes a lousy driving surface but makes a great crack sealant, is really helping to slow down the reflective cracking through our driving surface. And you can see that in this case study out there. Not only that, but you see that like with hot mix and microsurfacing and everything else, they typically will come back through as the same width as the existing crack. With the PressurePave system and our mix design that we have over the top of that, usually they come back as just a hairline. Now there can be additional movement, et cetera, where that gap's wider later on, but typically if that crack has done its thing, we're just going to come back as a hairline, whereas most other surface treatments out there, even hot mix overlays, will come back the full width and of the crack. That's important to note in here because, again, when you go in and say your program consists of, I do mill and fill, and when I go in and do mill and fill, I'm going to mill out 1 inch or 2 inches or whatever, and I'm going to come back with fresh asphalt, and I'm going to walk away, and I'm not going to have to do anything to that street for 15, 20 years. Well, that may or may not be the case, especially if you have not gotten to the source of where the cracking is propagating from. Again, reflective cracks coming back through from their origination. And so you can see from this photo, we were able to find that this milling project was in the process and they milled that out and did not get to the source of the cracking. And so you are going to get reflective cracks come back through even your fresh overlay. This was in Missouri. This was about a 2.5 to 3 inch asphalt overlay, again, illustrating the point with even thick applications of hot mix asphalt. Typically, those are going to re-crack at the same width as what you had originally. And if those cracks haven't been treated, now all you've done is you've gotten your cracks are now just 2.5 or 3 inches deeper than what they were. So again, with our pressure pave system, we feel like it's a more complete system. Is my driving surface going to re-crack? Absolutely. Again, I'm not, I can't retire quite yet, but there's been a lot of people over the years trying to spend a lot of money putting, fibers and all kinds of things. And we participate in some of those, and quite honestly, just haven't seen the cost benefit pan out in getting a driving surface to not re-crack. We've slowed it down some, but haven't mitigated altogether. So a long time ago, I said, the heck with it. I'm going to put down two completely different products, one that is highly crack resistant, and then my wearing surface that I know is going to re-crack. Just give you a few examples of how we use this system, where we put it down. This is in San Antonio, just about a year and a half ago, but we really like this photo because it really illustrates everything that we did for the city. They have multiple techniques they already use, fog seals, slurry seals. They have a variety of other tools in the toolbox for their maintenance, but they're really looking for us to be able to come in here and, again, on a PCI score that's lower, get away from the mill and fill process. So the photo really doesn't do it tremendous justice here, but you see somebody wrote fill. This was about 2 or 3 inches here that we came in and pre-filled with our driving surface material. I actually went in and sealed the cracks ahead of time with our sealant and then pre-filled it with our driving surface and let that cure, and then came back through with the PressurePave system to seal the cracks and then the wearing surface over the top. So this is a fairly busy collector that they actually allowed us to shut down and keep traffic off of it, but really showing the full toolbox of how we are able to not only just treat a road and save that road, but actually bring that rideability back. Many of our projects involve some sort of leveling to bring back the rideability. Because again, many times we are displacing mill and fill. We have very few really competitors in the asphalt maintenance treatment business. It's more competing for those mill and fills and really trying to save agencies those huge dollars in their mill and fill program.
If I could point out something on that last picture, just something that I know neighborhoods worry about, and those with businesses and stuff. So this material over on the right is fairly new. It was probably applied earlier that day. And the unique part of this as well is that it's chemically driven to dry. So it's going to have a similar dry time as it would be if it were applied at night. And what you see here is you might see a sheen on the top of this that is actually water being pushed to the surface chemically. And so say after 30 minutes or whatever the time is, cars are going to be driving over this and it's going to just be pushing water. And so you're not, you don't have to worry about tracking this into driveways or businesses after application. The only kind of tracking that would occur is a little bit of water on the tires.
This project was done at night. This is in Springfield, Missouri, where I'm located. Just kind of give you a little bit of a before and after, also illustrating, yes, we do put this on some heavy collectors. And by the way, Brian, and I'm going to throw you a curveball. This was actually our 1/4 of an inch on this collector that we put down, I believe, what was it, 12 years prior?
Yeah, so this is a reapplication of a surface that had been down without PressurePave, just the surface that we use for 12 years, and it's getting about 11,000 cars per day.
Yeah. And really, most you can't, and maybe not be showing up well, but most all of that surface is still there. Really, the reason we're coming back in is because of the cracking that is, some of the cracking that has occurred, reflective cracking. But they actually had us come in and do the 3/8 of an inch version now because they like it so well, because we now made it available and they loved it. So we actually came in and did that recently in that application. I'm going to show you some before and afters and really get to, when people talk about, how long does this last, et cetera, et cetera. I'm going to let you all be the judge of how long it lasts and what it does and how it performs. But I will stack this up against anything and really in evaluating any pavement preservation technique. I would really encourage you to seek out data like what we're going to provide to you today, which is really photo documentation and case studies of how long something will actually last versus just, you know, what we in the industry claim it will do. But this is in central Missouri. So this is pretty well central part of the country that gets some good snow events, gets some ice events, all those good things. But this is a neighborhood that was on their mill and fill list. And you can see that we're actually going to help come in here and bring this rideability back in some of these areas. Obviously significant cracking, but if it wasn't for the pressure pave system, they would be doing a mill and fill on this. Apologize for the shadows here on this, but we really like this photo because they're actually after a little bit of a moisture event, and you see some of the cracks that were just in the surface there a little bit. But again, we don't care because we know the pressure pave sealant is down below that, but we're actually able to really bring that surface back to something that they probably will not have to touch for at least 10, 12 plus years. Again, similarly on this same project, significant amount of cracking, and you can see what we're able to do with that and bring it back from the brink and from the mill and fill category. And again, these are roads that I will stake my reputation. They will not be doing anything to these for at least a decade, if not considerably longer. Up around Kansas City, we do a tremendous amount in the heavy municipalities of, you know, historically St. Louis, Kansas City, outside the Dallas area, and numerous ones, you know, kind of all around the country now. But for the most part, these are some of our longest roads that we've got in place. You see some of the before imagery here. What we're able to do, this is actually sunken down a little bit. We did not go in there and pre-fill this per the request of the city. They want to see what it would do. So this is after fresh stripes are on the road, and you see what we're able to do with bringing this back. And again, really the important thing is how long does this last? What does it look like when time goes by? That's what everybody loves to see, including me. And we see after 5 years, again, are we seeing the hairline cracks in the driving surface as we said? Yes, I'm not ready to retire yet. But we don't care because we know that that pressure pave sealant is still underneath there and doing its thing and keeping that road sealed. Again, some before and afters on this project. And again, just to give you an idea, after 5 years, you're seeing a little bit of reflective cracking coming back through. But as you also notice, not all of the cracks are coming back through. Just some of the more substantial ones have. But again, even so, that pressure pave sealant is down there doing its job. This was probably one of the worst ones we've ever done. This was a street in Waco, Texas. We did that had a PCI of 38. I said, thanks a lot, guys, for giving us a, they said, well, we want to see what you actually can do. Well, they did and we did. I'll let you kind of judge for yourself, but we actually had to come in here and pre-fill some of this because these platelets of asphalt were not, they were only slightly moving and they weren't coming out anymore. So we thought, okay, we're going to leave them. We're going to go ahead and put our sealant and our initial wearing surface in there to fill in that rutted area and then top it off. Then this is after 3 years. And this is, again, is an area that even likes to hold water, but you do see some of the reflective cracks coming through. But again, this is going to be one that they haven't touched yet, and they're not going to be touching for years to come. So how much data do we have to show how long our system lasts? Well, again, the pressure pave sealant part of this is really only come along in the last, 5, 6, 7 years. But the wearing surface I've been doing for a long time. So I've got some case study information for you to see. But even in the driving surface alone, prior to the pressure pave sealant, you can see from this photo, this was the treated area versus the untreated area. And this was 16-year-old asphalt. But you can see the moisture that is being held in there, again, after a little bit of a moisture event, and the cracks, the moisture in the pavement, et cetera, and you don't see that in our wearing surface. So again, That driving surface alone, the MAQS, the modified aggregate quickset that we have a patent on, is just one heck of a wearing surface and a sealant all to itself. And that's one of the reasons that we've been able to get the longevity out of it that we have. And if you talk to anybody in our industry that really knows this business, for us to be able to go in here and say, look, here's our case study. Here's a 10-year-old, 11,000 car a day collector that we're able to snap a picture of. And obviously it shows there's not a single car on it. I tell people it must have been during COVID or something, but for the most part, this is 11,000 car a day collector, and be able to come in here 10 years later and see that substantially all that wearing surface is still there is unheard of in our industry. And it really comes down to our aggregate and our mix design that we use for our wearing surface. We show this photo just to show after 14 years now in the wearing wheel path, showing just a little bit of wear going on. Again, after 14 years, this is really unheard of in our industry. So here's a residential street in Springfield, Missouri, where I'm located. Just kind of showing some of the reflective cracking coming through there, but our surface is still there after 13 years, after 15 years. We are showing just a little bit of maybe damage down here from a snowplow, but all in all, there's no loose aggregate in the gutter. The surface is still tight. This is all still our original wearing surface there after 15 years. So that's where we come and say, look, we can actually show you proof of how long our system will last. We really take a lot of pride in how well we hold up in cul-de-sacs. You cannot take a state spec genre of a slurry, microsurfacing, or anything like that and get it to perform well in cul-de-sacs. I have not seen it, and I've been doing this a long time, but we're very, very proud, and we show photos like this simply because we all in the industry, we know what damage can happen in a cul-de-sac, right? Here's the dualies from a trash truck doing donuts in it once a week, twice a week, etc. And it's that torsional twisting, turning that you don't get on a state highway. I tell people all the time, I said, I can look like a hero on a state highway. All I'm doing, yeah, there's a lot of cars, a lot of traffic. They're all just pretty much running up and down in straight lines all day. You get in here in a residential setting where you've got somebody coming out of their driveway, you got a trash truck the next day after you laid it, going in there and doing donuts in it, power steering in it, all that stuff. It just takes a completely different animal to be able to withstand that type of abuse, and we're very, very proud of it. One of the reasons that we do well in that type of scenario is because we don't have any handwork in our application. We actually have a patented device. We are tricking our equipment that is made to go in straight lines. We're tricking it to kind of go into arcs and circles and to eliminate handwork. And I won't dive into all the nuances of why, but it's a very, very special aspect of what we do. Yeah.
Sorry, real quick. Steve, how are we doing on time?
Yeah, we got about 11 minutes.
Okay.
Is that right? Yeah.
Okay. So
I can wrap it here, and we can take questions if you like.
All righty. So first question, do you wash and blow out the cracks? So do you sweep? I guess you sweep it because the fine cracks are going to be tough to, but I guess do you sweep a job before you go and do it?
Yes, we do broom the streets ahead of time. If they're really bad, we can get a vac truck out there. But we also, underneath these machines, have a blower that will, any additional loose stone or whatnot in those cracks will get blown out by the underneath the machine. We don't require, because of the way we do our system, it really does not require deep penetration of material into the crack. Matter of fact, you can actually, if you know doing crack seal, you can actually overblow out a clean out a crack, and then you got to go back with sand or something else, or backer rod or something to fill it back up again. You really, all you're trying to do is get slight penetration into the crack and put this material over the top of that. So it really does not require deep penetration, deep cleaning to achieve what we're wanting to achieve.
And I think you addressed someone, it's actually CJ O'Neill from Matthews asked, how do you handle cul-de-sacs? And the picture right here shows it, and the equipment's smaller, right? We were looking at a big train, usually like cold in place recycling. You're not going to get a train like that into a cul-de-sac, but obviously you can handle the cul-de-sac with the way that you're handling it here. I had a question. So at some point you're going to mill this up, right? How many applications have you done? Have you applied multiple applications and locations?
The most so far is 2, and that's because, quite honestly, our wearing surface has lasted so long. Our initial wearing surface, and again, I've been doing this, pushing 20 years, but we're just now, and many of the agencies that we work for are now going back for the second application. And again, primarily to address the reflective cracks and some of the things that come back through and freshen that up. So it's a great question. I'm glad you asked it, because it's important to know that our goal, what we're trying to help our customers with, is to prolong the mill and fill process just as absolutely long as we possibly can, because that's expensive, right? And so we do that. So this is a perpetual program. This is something that we've already shown many of our customers here in the Midwest and South, is that we can come in and put down something that will last 10, 15 plus years. We come back in and do another 1/4 of an inch now with a PressurePave system to address all the cracks, and put our fresh wearing surface over the top of that. How long that is going to last is, quite honestly, I'm not even sure, because I know it's going to last every bit of 10 to 15. Is going to last longer than that, I don't know. But for the most part, yeah, this is a perpetual program. We're literally decades after the initial application. You may be looking at a mill and fill, and how long in the future that would be, time will tell.
Hey, go ahead.
Go ahead. Oh, I was just going to say, this image is actually taken in one of the places that we've done this, and that's Olathe, Kansas. They spend about $2.5 million with us every year. And they're just now this year going over something that we did 13 years ago. So anyway, that's part of their program coming up, and they're one of the first ones to do it, just because, well, I take that back. There's about 3 or 4 that have been with us for more than 10 years, and they're going over and paving over stuff that's 13, 14, 15 years. So anyway, just to kind of give you guys an idea of where they've done it in the past.
Hey, so we have a client, Clint Blackburn in Durham. He's trying to achieve a 50-year cycle from when you first pave it until you have to go mill it up. So, he's not on here today, but we'll definitely let him see the link and be able to watch it. Hey, so sometimes, is there any problem when you mill this up and bring it back to the plant? Are they going to have problems with the millings, or is there anything in here that they wouldn't take back?
No, not at all. This is limestone aggregate in various forms of it, and it's polymer modified asphalt. It's 6422 base stock asphalt, polymer modified. It's more similar to a super pave than anything. But yeah, no, completely compatible. You treat it like any other asphalt.
Excellent.
That includes markings, whether it be paint, thermoplastic, any of that. Many of our customers want to know about that, and yeah, those are bond quite well to it. Typically, we do remove markings ahead of time. Now, this PressurePave sealant is one heck of a gorilla glue. And we have been asked in times to put this over the top of thermoplastic, which I'm not a big fan of doing that, because I don't have the data that backs that up yet. But we're going to find out now. But some thin paint and things like that, we can go right over the top and don't remove it. But typically, we kind of like to stick with the industry standard of any thick paint or any thermoplastic, try to remove that ahead of time for a variety of reasons. But we're only going to be as good as what we can bond to. So if that old paint or that thermo is going to eventually delaminate, we can't help that too much.
Hey, you mentioned plows. Someone asked, any special consideration for plows?
No, I'll just give you the story that when we first did this, many years ago, the guys in the county we were working for said, "Oh, that snake oil, we're just going to plow that right off the road with our graders in the winter." And they found all they did was sharpen their plows. It's unbelievable as far as the wearability that you get out of this. It's impressive.
Hey, so someone asked about the PSI for the treatment when it's pushed down into the pavement. How many PSI is it?
I don't have that number off the top of my head. The boxes are pressed to the pavement, and then how many PSI that is, but I've never. The guys, I think maybe we put a gauge on it before about how the pressure inside those chambers. I just don't have that number at my.
Okay. Hey, so we're getting close here on time. Someone asked, are we going to be able to see this out in the field? And the answer is yes. We're working on the contract for Lexington, North Carolina. So folks in North Carolina can easily get there, and you're more than welcome to fly here from other states. But we're going to try to shoot to have a lunch and learn in the field, preferably once the project starts and get it moving. One last question. How many square yards are we looking at for someone saying, hey, I want to do a pilot? How many square yards would they need? And then how much would, a typical unit cost would be for this application?
I'll answer the last question first. It really depends on, where we're located in the country with mobilization costs, and there's just a lot of factors. And I don't mean to deliberately be vague, but
Right.
it really does vary quite a bit depending on the size of the project and getting those materials to that site. I will say this, that our goal is typically to be half of what a mill and fill is. And usually we can hit that, if not better than that, depending on which part of the country that we're in. As far as the size of the project, our guys, we send a crew of usually about 30, 35 people out there per project. So, and usually what we're trying to shoot for is at least 2 or 3 days worth of work. Our guys will put down anywhere from say 15 to 25,000 square yards per day, whether that be residential with cul-de-sacs or collectors or whatever. They'll generally hit those numbers. And so usually to get the best pricing, we try to shoot for, at least 2, if not 3 days worth of work going to an area. So 50 to 60,000 squares usually is what people try to target for a starter.
And it helps too, if, for example, one city wants to do a project, if another city wants to join in, or the city and the county or whatever, the more quantity that is in that general area, that's going to help the unit price going forward.
Hey, assuming the contract goes through, when were you guys shooting for trying to get this done in Lexington? I know this is kind of, we're out there. I don't know if you guys are there yet, but any idea?
Don't have a firm time on that. It would be during the summer months. Typical application time for us, we start in the south. Obviously for obvious reasons, we'll start in about mid-April to May, work our way back up into the middle of the country, generally June, July, August, September, and then work our way back down south again, whether it be Texas, Florida, Alabama, or wherever we are. So somewhere in those middle months is probably where we'll be in North Carolina anyway.
And we know that their fiscal year ends in June, end of June. So we'll try and shoot for before end of June.
Oh, okay. Yeah. Good point.
Good answer. Good answer. So, all righty. Well, we're out of time here, and Mike and Bryant, we really appreciate you giving the presentation. It was very interesting, and thanks everybody for attending. Our next Lunch and Learn is going to be on February 26th at 11:30 a.m. And the topic is automated data collection methods, pros and cons, and it's going to be given by Eric Botting from ARB. So anyway, again, thanks for everybody attending. If you're interested in that lunch and learn in the field in Lexington, just shoot me an email. We'll send you the information once we have it available. Everybody have a great day.
Thank you. Appreciate your time.
Take care.